Hi. So today we will discuss a test question that I designed for my student. So this is the first 81, the question booklet. If you want to try it, I will put it on my Google site and share in the description later on. So this is a question. So the first question, diagram below shows a function fx within the interval from 0 to 6. A few points are labeled. Identify the largest possible domain of fx such that the inverse function exists. So essentially for this particular question, you just look at all the possible domains whereby when you draw a horizontal line, when you perform a horizontal line test, it will pass as having a one-to-one function. Then you identify which one is the largest. So the only possible way you can sort of like have one-to-one function is between 0 to pi over 2. So that's one possible region. From pi over 2 to 3 pi over 2, that's another possible region. And from 3 pi over 2 until 6, because the domain already stated is from 0 to 6. So then you just need to identify which one is the largest. I think the largest would be, sorry, so I will write in black. So the largest would be from pi over 2 to 3 pi over 2. So each of the left limit gives you one mark, the right limit gives you another mark. So this is the only answer. If you calculate from 6 minus 3 pi over 2, this is around 1.288. Whereas from 3 pi over 2 to pi over 2, here you have pi as your region. And then the other one is pi over 2. So obviously the largest would be from pi over 2 to 3 pi over 2. For this domain stated in A, identify the range of 1 over fx. So this is not the inverse function, but rather you need to look at this particular domain. So this is a domain that you need to look at. And then you identify the reciprocal function. So essentially, you have one vertical asymptote over here. So let's say this is your y-axis and this is your x-axis. So there is one vertical asymptote over here, and then from pi over 2 until 3.74907, essentially this is positive. So over here, 1 over 1 is still 1. And then when it approaches 0, you will go to infinity. Then the second region, up to this point. So this point, the y value is already given. So you have minus 1 over 0.41615. So this point will be around minus 2.4. And then because this portion of the graph is negative, so it curves downwards. So then the range of 1 over fx is quite obvious at this point. So you can write 1 over fx is given by this particular range, which is from minus infinity until minus 2.403, for example. So you should close it with so the bracket will correspond to what you write on top. If you write open interval like this, then this has to be open interval as well. But since on top I write the closed interval version, so you need to write the closed interval. And then you have a union. So now you look at the positive part, which starts from 1 until infinity. So that will be your answer. So again, at this point, the first portion is 1 mark, the second portion is another 1 mark. Okay. Question 2. Let fx to be log base 0.5 x minus 3. State the domain of fx where the function is defined. So domain of fx will be from 3 to infinity. This is an easy question, so you will just get 1 mark. So whereas over here you can easily make the mistake, so which is why I divide into 2 marks over here. But this is just reading from your logarithm graph, so which is why it's just 1 mark. So you want to show the change of base formula. So the first step is already given, log BA equals to x. So what you need to do is to return back to the original definition and then taking logarithm base c on both sides. So you have log base c bx equals to log base ca. So over here you can make use of putting down the index, sorry, not index, the power x. So then you have x log base cb equals to log ca. So I erase this part because it's just identity. So therefore x equals to log base ca divided by log base cb. So what is x? X is log BA. So log BA equals to log CA over log CB. That's how you prove this change of base formula. You have 2 marks. So I would give this portion 1 mark and then this portion 1 mark. So the last step basically is already given. So that's why it's only 2 marks. By using the change of base formula, change the logarithm base of fx to base e. So fx is log base 0.5 x minus 3. So if you use the change of base formula, you will have log, sorry, if it is base e, you can just write ln. So a would be x minus 3. So you have ln b is 0.5. So over here you need to be careful because ln 0.5 is a negative number. So you have a negative number and then you do the reciprocal. So is minus 1.4427 ln x minus 3. Or you can just write minus 1 over ln 2. But having the value written down helps you to do part D, because then you need to state two transformations that will transform your fx to gx. So just take note what has changed. So first you need to reflect on your x-axis. Okay. Then the second one, because 1.4427 is greater than 1, and in order for you to go back to ln x minus 3, you actually need to compress. You don't need to stretch, you need to compress. So the compression factor is compression in the y direction by a factor of ln 2. So essentially you need to compress by a factor of 1 over 1.4427, which is 1 over ln 2. That's why the compression factor is by ln 2. Okay? So this is 2 marks. 1, 1. Over here, just use the change of base formula. As long as you get it correct, you should get 1 mark. Question 3. Ecologists study a species of water beetle, estimate the population of a colony of a 8-week period. So if t is the number of weeks after the initial estimate is made, so take note that t is from 0 to 8. So this is the equation. The initial population. So because you don't really, so this is a sine graph, and you don't really sort of like move from left to right. So initial population will be at t equals to 0. So sine 0 is 0, so you have 5. So it will be 5,000. Take note of this. So what were the smallest and the largest population? So then you need to think about when you would get to the highest, and then when you would get to the lowest. So your graph basically looks like this. So this will be somewhat like your graph. And then your over here will be 5. So you need to figure out when is your sine x to be the largest. Largest will be when sine pi t over 3 equals to 1, right? So that happens when t equals to so when will that happen? When your t equals, so essentially this happens when pi t over 3 equals to pi over 2, because remember that when your sine 90 degree or pi over 2, it gets 1. So largest will be 5 plus 2, because over here this is 1 times 2, you get 2. So it will be 7, or in terms of thousands, you will have 7,000 water beetle. Smallest, it will be when your sine pi t over 3 is -1. So that happens when it is 3 pi over 2. So let's check whether this is possible or not. Pi t over 3 equals to 3 pi over 2. T will be 9 over 2. So it is 4.5, so this is possible. Therefore, the smallest will be 5 minus 2, which is 3. And in terms of beetles, so this will be 3,000 water beetles. So these are the number of marks. During what time interval did the population exceed 6,000? So then you need to look at this particular equation. 5 plus 2 sine pi t over 3 is 6,000. So 6. So 2 sine pi t divided by 3 would be 1 over 2. So now you need to look at these solutions. Over here, I don't really need to write this. Technically speaking, you can, but it will just sort of like cause me more trouble. So it is better that I find all the t intervals and then I identify which one is greater than 6,000. So inverse sine of 1 over 2, that will give you pi over 6. So I can simplify the pi, so t would be 1 over 2. So what else? The other interval would be at the second quadrant. So the second quadrant will be at pi, so 5 pi over 6. And then you go back. The reason why you need to go back is because you need to fulfill this particular condition. And so this is the domain that you need to study. So you multiply by pi divided by 3. So 8 pi divided by 3. That will be around 2.667 pi. So you need to look at all the possible values until 2.667 pi. So the next one will be 7 pi over 6, which is not 7 pi over 6. It will be 2 pi plus pi over 6. So it's 13 pi over 6. So that will be equals to 2.167, so which is still within the range. And then the next one will be outside of the range. So this is the last one. Okay. So then you simplify with the equation. So your t is either 1/2 or 5. Let me simplify it. 5/2. And then the last one would be 13/2. So now let's look at your sine graph again. So this is 5, 6 will be around here. So we know that the first intersection, this one has to be 1/2. This one has to be 5/2. And then the next intersection will be here, 13/2. So 13/2 is 6.5. And then 8 will be roughly here. Because the next value, 2 plus 5/6, there will be 2.833. So this one definitely is more than 8. So that's why we can conclude that the time interval is between 1/2 to 5/2, and then the second interval will be from 13/2 until 8. So these two interval, 1 mark, 1 mark, and then finding this 1 mark, this 1 mark. So total you have 4 marks. Question 4, investment per annum compounded yearly, withdraw when it reaches 25,000. So the total amount after the first year, so it will be, let's say I1, that will be 15000 multiplied with 8.4 divided by 100 plus 15000. So the first term is the interest, second term is the original investment that you put in. So in short, this is 15000 times 1.084. So this will be 16260. Second year will be this multiplied with this. If you are familiar with investment and compound interest, probably this is a very easy question. So if you are not, how do you calculate the second year? Alternatively speaking, you can do this. So you take 16260 times 1.084. But 16260 is 15000 multiplied with 1.084, which is why I can write the left side. So if you calculate, it should give you the same answer. Sorry, there's a 1 missing. So calculate the fifth year, so that will be I5. And by now we should already establish some sort of pattern like this. So that will be 2245.10. So it is quite close to 25000 at this point. So based on your calculation above, write down in the equation involve the following variables. So Tn is the total of saving after n years, so you put Tn over here. T0 is the initial investment. R is a constant, and you need to state the exact value of R, so it's 1.084, and then n. So that will be your equation. So let's write down all the marks first. This is 1 mark, 1 mark, 1 mark. So the whole equation 1 mark. This particular value 1 mark. So after how many years he will withdraw the money? So 15000 times 1.084 power n has to be greater than 25000. So that will be 1.6667, taking the natural logarithm on both sides. So n will be greater than ln 1. Answer divided by ln 1.084. So your answer should be this. So n should be 7. So over here, able to formulate this, solving this, and finally this. So usually when you see this type of questions, the final answer usually is given 1 mark because you can't have 6.3 years, for example. From answer in E, how much extra money Dean will receive? So you calculate T7 following the formula. T7 will be 15000 times 1.084 power 7. So that is this value. So you need to calculate how much extra money. So you use your answer in the previous equation minus 25000. Yep. So that will be around this value. Question 5. Find the value of k for which equation has a repeated root. So it means b squared minus 4ac equals to 0. So it's k squared minus 4ac equals to 0. So k will be equals to plus or minus 4. Okay. Now show that the equation. So you make use of b squared minus 4ac and you find the value. Show that the equation can be written as this. So you have 4 sine square theta equals to 5 minus k cos theta. So sine, you use the sine square plus cos square equals to 1. So this is 1 minus cos square theta. So then finally you just rewrite everything. So finally you have 4 cos square theta minus k cos theta plus 1 equals to 0. So over here, this one, and then rearrange, you get 1 mark. Let fk theta equals to that. State the number of values of cos theta that satisfies the equation. So notice that this has exactly the same as this form, and when k equals to 4, you only have 1 cos theta, so answer will be 1. So this will be 1 mark. Find all the values in the interval from minus 2 pi to 2 pi that satisfy the equation. So, okay. So 4 cos square theta minus 4 cos theta plus 1 equals to 0. So if you factorize it, you have minus 2 cos theta minus 2 cos theta. So in the end you have 2 cos theta minus 1 square equals to 0, or cos theta equals to 1 over 2. So take note of the interval that you need to solve this. So theta will be equals to plus or minus pi over 3 plus or minus, so it will be 2 minus 1 over 3, 5 pi over 3. So those are the values. So 1, 2, 3. Find the value of k for which x equals to 1 is a solution. So just substitute. When x equals to 1, 4 minus k plus 1 equals to 0. So k would be 5. For this particular value, find the solution for that interval. So you have 4 cos square theta minus 5 cos theta plus 1 equals to 0. So again, you factorize this first. So in the end, you would get 4 cos theta minus 1 cos theta minus 1 as your factors or roots. So cos theta equals to 1 over 4 or 1. So let's look at cos theta equals to 1 over 4 first. So what are the solutions? So theta would be plus or minus 1.32 radian, and then the other one would be plus or minus 2 pi, sorry, uh, 2 pi minus answer 4.97 radian. So this is the answer for cos theta equals to 1 over 4. So if you look at cos theta equals to 1, theta would be 0 plus or minus 2 pi. So that will be your answer. Finding the factor, finding the answer for first part and the second part. That's all. Thank you.